The data is rectangular. Now, right away, that has pluses and minuses. The plus is, it's a very regular model, so it's easy to understand, and we can make it go really, really fast. The downside is, if you've got irregular data, you have to start worrying about the holes and the irregularities, and it doesn't really fit this model. For example, I'm assuming that everybody actually has a gender. Okay, probably a reasonably safe assumption, but suppose I drop this table, I get rid of this table, and I create table people with gender, text, name, text, and address, text. Insert into people, female, Lady Gaga, 123 Broadway, New York City. Right? What did I miss? Oh, insert into people, space, values, like that. Okay, insert into people, values, male, Coffin Henry. What do I put for Coffin Henry's address? He's homeless. I'm serious.
Empty string.
Empty string? Okay. Now, what if you've got an address but I just don't know it yet? It's different, isn't it? All right. So right away, we get into a problem that isn't really the database's fault, but this is where most people have to deal with it. What do I do about missing or incomplete data? Okay. Do I have some special value for homeless and a different special value for in the process of changing addresses and a different special value for, military service, and therefore send all of the mail to the U.S. Army and they'll forward it? Do I have, on the road, etc.? Okay. And if so, how do I pick a special value that I know will never actually be one of these actual values? There is a town in Ontario called Homeless. All right? Think about what that does to government databases that are poorly designed.
You put a new field.
Put a new field in. Okay, so right away I want to step away from this and say, do you have an address? Yes, no. If so, what type of address is this? Is this a permanent address? Is this a forwarding address? Is this a... Okay, so my table's starting to become complex. You might actually have several addresses. Right? I have 3. I have my home address, I have my office at the university, and I have my office downtown. Okay, so how do I signal that in a database? This is a data design issue, and coming back to your question about what do you put where, it's almost the same problem as how do I organize my code, or what does each function do? How do I take the stuff I want to save and break it up into manageable pieces? And this is what we'll do an exercise on later this morning. Once you've answered the question about what am I storing and what does it mean, designing the tables is the easy part. It's just many people they say, wow, table design is hard. No, thinking about your information is hard. Once you've done that, the easy part is writing it down. Let me give you another example that I tripped over this morning. What information do you store about a music track on an album? I'll pick on you.
The length bit.
Okay.
The
Title, artist?
Yeah.
Okay, what if you don't have either? What if you've got a piece of folk music recorded in the 1950s? You don't know who recorded it, when exactly it was recorded. You know it was sometime between 1951 and 1955. You don't know who the artist is, and you don't know the title of the song. Okay. What do you store as identifying information? You can store track 03 as the title. Except many other albums will have a track 03, which is not the same song at all. Right? Because they didn't know the titles either. What do? Okay? This is not a database problem. This is an information management problem. But you have to deal with it. It's just here's where your fuzzy thinking has to turn